what that means practically speaking. All right, so, I'm a little concerned. I just want to make sure that's actually streaming. All right, so I'll give you a minute to get there, and I'm going to make sure this is actually streaming, because I've been struggling technologically this week. Go away. Sorry? I'm just making sure it's actually streaming, because if it's not actually streaming, then I'd be sad. Oh yeah, I'm live. Look at that. Excellent connection even. All right, so there we go. So we want to talk about pure substances and about mixtures. So in our last unit, we said that in our last lesson, we said that if you took any physical object and cut it into pieces and keep cutting, eventually you would get down to just a single particle. And what did we say those single particles were called? Atoms. Good. So today we're going to talk about how scientists like to classify matter. And remember, matter is anything that takes up space and has mass. Yeah?
Question number 1.
Yeah?
Can I try and answer?
Oh, sure.
Are they not like you know how there's like hydrogen? Are they not things that are just made up of one thing, like just one atom?
Yeah, that is one of the two cases we're talking about. Yes, for sure. So pure substances can be defined, and you're on exactly the right track. Any substance, that was an awful looking S, but here we go. Any substance made up of only one type of particle. In other words, if we wanted to kind of put it in the vernacular, we could say each building block is the same. So if you had a wall and every single brick in the wall was the same kind of brick, that would be a pure substance. If, on the other hand, you had a wall and it intermixed different kinds of bricks, then that wouldn't be pure substance. I'm using brick as an analogy here. But so if you took any pure substance and you dug down and dug down and dug down, you would find that all the particles that make it up are the same. Now, how did I word this? Oh, I like that. That doesn't necessarily mean, though, that every particle is the exact same atom. Because there's two kind of categories here, two things we can look at. The easy one is they're all the same atom. All right, in the first case, we could say all the same atom. In this case, each particle is just one atom. So if you had like a piece of aluminum in front of you, aluminum is a pure substance. And aluminum is actually a type of atom. So if you had a strong enough microscope and you could dive in and zoom in and zoom in and zoom in on your aluminum can, you would find that every single atom is an aluminum atom. It's a pure substance. We call this, by the way, an element. The word for this is an element. So the different elements are the different types of atoms. Hydrogen is an element. If you have hydrogen in front of you, every single particle is a hydrogen atom. Gold is an element. If you have gold in front of you, every single atom is a gold atom. So that's the first possibility for a pure substance. But the second possibility is similar, but how did I word it? Each particle is a group of atoms put together in a specific way. And we call a group of atoms put together in a specific way a compound. Now, it might be a little weird to think that something can be pure if it's made of more than one type of atom. Isn't the whole point of pure that everything is the same? This, to me, is kind of a confusing definition. I don't like it. I don't like things that confuse me, and that confuses me. So it can help to look at some examples. So if we were thinking about a pure substance, what could we think about? Let's draw some pictures below. I'm going to think about three things and we'll talk about them. The first thing we're going to think about is an iron nail. Maybe when this teaching thing falls apart for me, I'm going to become a blacksmith. I think I'd be a good blacksmith. I can see me wearing aprons. I think I'm ready to be at the stage in my life where I wear an apron every day. So if I made an iron nail, and again, try not to be intimidated by my great art, but ready? There's my nail. Doesn't that look good? Who said no? Oh, you hurt my feelings. That hurt my feelings. I didn't like that, but that's okay. And if we were to take this and zoom in on just this section here and actually zoom in very, very finely, what would I find if I were to look at this? If I could actually see the individual atoms, I would see an iron atom and an iron atom stuck to an iron atom stuck to an iron atom, right? That's what I would see. Is that a compound or is that an element? That's an element. Good. It's an element because all of the particles are the same particle. By the way, if it was a steel nail, that'd actually be something a little different. We'd have to talk about that. But for an iron nail that I forged in my blacksmith, in my imaginary blacksmithing career, there we go. On the other hand, what if we looked at pure water? I choose water because water is one that just about everybody knows what it is. What is the formula? What is water made of? It's not just one atom. There's no such thing as a water atom. You can look all through the periodic table, all through science. You're not going to find a water atom. That's not a thing that exists. Very good. But pure water follows a very specific recipe. A very specific recipe. And he just told it to me. It is 2 parts hydrogen, 1 part oxygen, H2O. You've probably heard that before. Which means if I have here a nice cup of water, again, try not to be intimidated by the beauty of my drawing. I am intimidating, I understand. But if I was able to take here and view here, again, am I going to find water atoms? Is that a thing that exists? No, that's not a thing. What instead I'm going to find is that water is actually made up of an oxygen stuck to 2 hydrogens. And every single water molecule is going to look exactly like that. Not just one atom, 3 atoms, but it's a really specific recipe. And so we still consider it a pure substance because it's not a random collection of things. It is this very fixed recipe. You don't have to worry about drawing this because I'm going to send you all of the drawings. But I'd maybe put the words there. So is this an element or a compound? It occurs to me that those oranges don't look very different than the yellow up on the projector. So I'm going to redraw that with a better color palette. I want it to be really clear, so maybe we'll have 3 water molecules here, and that means we need 3 oxygens, and each of those is going to be stuck to 2 hydrogens. Kind of like that. And we can say here that oxygen stuck to 2 hydrogens is water. And is that an element or a compound? Compound. Good. The reason we can prove that is because we can actually, in the lab, we can break this apart even further. It's possible to take water and break it up into its 2 parts, to make hydrogen gas and oxygen gas out of it. If we get around to it on Thursday, that might be one of the things we do in the lab. We take water and we break it into its parts. Get ourselves some hydrogen, get ourselves some oxygen. Will we be able to see it? Yeah, well, I mean, we'll talk about that. And, I mean, I could look at a third example just to see how we're doing with this. What about table salt? Does anyone know what table salt actually is? Sometimes people just say it is sodium, but it's not just sodium. By the way, if anyone ever invites you to eat just sodium, don't, because sodium is a metal that is highly reactive. When it comes into contact with water, it bursts into flames. So if you put sodium in your mouth, that wouldn't be good. That'd be uncool. So it's sodium chloride, which you don't need to worry about too much about it, but what are the 2 atoms that make up table salt? If I just had this pile of, I don't really know how one draws salt, I guess. Ready? Ready for this? Amazing piece of art. Who just said no? That hurt my feeling. That's a box of salt. And then there's like and there's salt. See, isn't that good? That's good art, right? I know, I'm good. Don't be intimidated. But if I actually looked here, I would see that this, usually, let's see what we're going to do. We're going to do that for our color scheme. Salt is an interesting one because it's this kind of network pattern where every sodium is surrounded completely by chlorine, and every chlorine is surrounded completely by sodium, and it's in a 1-to-1 ratio, which is kind of fun. So you could just keep drawing that all day. I'm not going to draw it all day, but there it is. So equal parts sodium and chlorine atoms is sodium chloride. That's table salt. And again, that's a pure substance, but is it a compound or is it an element? It's a compound. How do we know it's a compound? You're totally right. Very good. Every single particle you look at is going to be the same. It's going to be one sodium and 1 chlorine, but it's 2 different atoms. So that's a compound. So we've got a nail, we've got pure water, we've got table salt. We can kind of use those as examples to think about. Does that make sense? Yeah.
Can you minute that? Like, I know it's close, but like actually I'm really bad.
No problem. How's that? And again, I'm going to give you this drawing, so you don't need to worry about drawing it. I'll send those your way. I'm going to distribute at the end of the day just a sheet to everyone's section in their OneNote that just has all the drawings I made today, so that you can share in my artistic wonderment. But there we go. So, by definition, then pure substances have all the same particles. And that may mean each particle is just a single atom, or it might mean that every particle is a group of atoms, but not a random group of atoms. Not random, always a fixed recipe. That's important. A compound has a very specific recipe, right? If I just took a bag of flour and threw it next to a bag of sugar and a thing of eggs, would I be allowed to call that a cake?
Yep.
I mean,
Right? When this teaching thing falls through and I get fired for commenting on dousing myself in oil before jumping in water, which we can all agree is a weird thing to be talking about. If I then get a job as a baker and somebody hires me, and then maybe like Hayden's like feeling sorry for me that I got fired, he's like, I'm going to hire this guy to make me a birthday cake. And then he shows up and I just hand him a bag of flour and a bag of eggs and a bag of sugar. Is he going to be like, oh, thank you for the delicious cake, Mr. Orlando?
Yeah, just take
I mean, first of all, he probably won't be calling me Mr. Orlando at this point. He'll be like, listen, Joe, that's not a very good cake. Yeah.
You could maybe be delivering ingredients.
True. Yeah.
There's actually this one video on YouTube that it's a mathematical food theory,
Yep.
and it's you don't need to add eggs to the box of cake,
Ah.
and that's when a big cake tells you to lie, gets you to buy more, because
Huh.
they make you think they're actually doing something.
Wow. That's good to know. I'm going to try that, and then I'm going to eat the whole cake. I'm going to make two, one with eggs, one without, and I'm going to eat them both, and I'm going to like it. So, to be a compound, it's not enough just to be the ingredients. There's a fixed recipe. This is water, but if I took one oxygen and stuck another oxygen to it, and then stuck hydrogens here like that, that isn't water anymore. Yes, it's oxygen and hydrogen, but it's a different recipe, it's a different thing. This is something called hydrogen peroxide. It's a totally different compound. It's a different thing. The recipe matters. Does that make sense? If you cooked and you put twice as many eggs in, it's going to change the recipe. It's going to come out different. Does that make sense? So chemistry is very much baking. It's not just what ingredients, but it's the recipe. It's how they're put together. Pure substances have one phase. One phase. And a phase is just a word that means its physical appearance. So that's boring to talk about here, but because all the particles are the same, if you look at an iron nail, it's going to look consistent throughout, right? One piece of iron should look the same as any other piece of iron because it's the same particles. Water all looks the same. Now we know the one way we can change that phase is how. The one way you could make two pieces of water look different is by changing the... What could I do? I could take one, yep. Well, no, but then I'm putting new things in. Oh, come on. The easiest way to change it, so like, I have water here and I have water there, but now I've made them look different. What did I do to this one? Sorry?
Change the shape.
We could change the shape, sure. Even more, we could change the temperature, right? Yeah, if I heat it up, it's going to turn into a gas, and if I cool it down, it might turn into a solid. So that's the only time pure substances can have different phases, is if they're in different states. But otherwise, a piece of water from Mexico, if it's pure water, will be exactly the same as water from Lake Ontario if you purify it, exactly the same as water from the ocean if you purify it. If you take everything else out, the water itself is the same no matter where you get it. The water that's on Mars is going to be the exact same as the water that's here because it follows a very specific recipe. Does that make sense? All right. So, one phase. Now, if something isn't a pure substance, then what is it? That is true. What do we call something that isn't a pure substance? When we put things together. When we put things together, we mix them. Good. So we call it a mixture. It's exactly what it sounds like. A mixture is a mixture is a substance that combines more than one element or compound. So if I take gold, which is an element, and I take copper, which is an element, if I put them together, I now have a mixture. There's some gold and some copper. If I take water, which is a compound, and gold, and mix them together, now that's a mixture. It's gold and water. If I have salt, which we talked about before, which is a compound, and water, which is a compound, when I put them together, I have salt water, which is now a mixture. Makes sense, right? Well, it has its purpose. You wouldn't say that if you were a shark, now would you? You'd say it was a life-giving environment for you to live in.
I wouldn't be able to say anything about
To say nothing, like your blood plasma is salt water, that's important. Without that, you'd be like in real trouble. So, it's got its role, but not nice to drink. There's two different types of mixtures. All right, the first is a mechanical mixture. And this is a mixture where you can see the separate elements. Oh boy, separate. Here we go. Oh boy. Separate. Oh man. Different it is. AR? I see. This is just a mixture where you can see the different parts. In science speak, we say it has more than one visible phase. But that's just kind of, unnecessarily complicated. It's a mechanical mixture if you can see the parts. All right? For example, if we go back to our examples from the previous page, if I were to take water, so after I've lost my teaching gig, I became a baker. I lost my baking gig because I didn't actually bake. I just put the ingredients in a bag and gave them to people, and for some reason they were dissatisfied with that. Now I'm getting really desperate, so I've decided to get into multi-level marketing. I've decided to be one of these people who's like on Facebook, which is something your grandparents know about, ask them sometime, and who's like, hey, I've got this amazing business opportunity. I'm selling blank. And if you sign 5 people up, you can make $6. I don't know, something like that. So I'd start my multi-level marketing scheme, and I think, well, what do I have here? What am I going to sell? And I'm going to sell like one of these health tonics, where people are like, hey, here's this thing that I've made, and it cures all kinds of diseases. And what did I have lying around? Well, I had some water. All right, so I got my water. I had some nails lying around. Got my iron nails. Yeah, so I'm gonna turn this into a thing. Because I also had my blacksmithing career, which I don't really know why that one didn't turn out. Sorry? Yeah, I'd love to. And so with these, I'm going to combine to make the new health sensation sweeping across Canada, Mr. Orlando's patented nail water. All right. Yeah, it's a real thing. It's a craze. It's a craze, all right? There we go. And it's expensive, let me tell you. It's not cheap.
Usually slides down your foot. At the right angle.
Okay, so I've made my new health tonic, Mr. Orlando's patented nail water. Of course, I put an apostrophe there because we all understand the apostrophe shows possession in English grammar. And I have good grammar, right? No. Yes, the word you're looking for is yes. All right, this is what we call a mechanical mixture. a mechanical mixture. You'll also sometimes see the term suspension. But really, it just means we can see the parts. All right? We can see the parts. All right. All right, and there's a word we use for this. There's one thing you'll discover in science is that like 50% of learning science is like understanding the concepts and the ideas, and then the other 50% is trying to figure out the obnoxious words that scientists have come up with things. And that is truly a problem. Like, it's something I don't think science actually does really well. I think sometimes we throw a lot of language. And this is a great example where this one pretty simple idea, right? You can mix things together where you can see all the individual parts, where that is like, it can be called a mechanical mixture, it can be called a suspension, or we sometimes use another term that you'll see, and that I have a habit of misspelling, so I'm going to ask somebody to spell check this for me. But we say that it is a heterogeneous mixture. And I have a habit of occasionally putting an extra E or omitting an E, so if somebody can spell check that for me, you'd be my hero. Yeah?
Don't a lot of the words in the English language come from Latin?
Yeah, a lot from Latin and a lot from Greek, but also a lot from French, because the English were conquered by the Normans, and also a lot from Germanic languages, because we were conquered by those guys. Basically, the English language is a case study in all the people who conquered the English and left their words behind.
Is that why it's like super complex?
Yeah, sure, right?
The hardest language to learn in the world.
Yeah, it's awful. Even to the point where, like, our words for animals are, like, come from the Old English. Cow, pig, lamb, whatever. And then our word for the meat that comes from them, they're just the French word for that animal. Right? So a cow gives you beef, which is le boeuf, which is just the French word for it. A pig gives you pork, which is just porcon, which is just the French word for it. Or ham, jambon, right? Which is just... So all of our words are just, they're just conglomerates of other languages of people who were stronger than we were. English is a really stupid language, but that makes it profoundly wonderful. Like, its ludicrous complexity also makes it kind of beautiful in its own right, but I wouldn't want to learn it, that's for sure. So what does this word mean? Well, genius isn't actually a great use of that. It really means to make. It comes from Genesis, the same root as Genesis. But this word should jump out at you. Hetero is a word that comes up a lot. We most often think of it in terms of sexuality, right? This is somebody whose sexuality is such that they identify themselves as being attracted to people who are of... a different gender from theirs, right? And so hetero means different or other, right? So if your sexual identity is heterosexuality, it means that you find yourself attracted to people whose gender is different or other than yours. So heterogeneous mixture comes from the fact that we can see the different parts of it. We can see the other parts of it. Not a great word, really. Like, it's kind of confusing, but it comes up a lot when we talk about something being heterogeneous or homogeneous. Gotta know the difference. So heterogeneous is there, and it means different or other. It means we can see the different parts. There we go. One simple concept, 4 different words for it. Yay, science. Love it. But if you think about it, those words all make sense. They all make sense. All right. So that's a mixture where we can see the different parts. What's an example of a mixture where I cannot see the different parts? Yeah, sure. Sorry? Sure, a lot of drinks, right? A lot of drinks just appear clear. They may be colored, but they're clear. It all looks the same. Yeah.
I was going to say Kool-Aid.
Kool-Aid, sure. Salt water, for sure, right? You put salt in water, as long as you don't put too much of it, you stir it up, it just looks like water. I used to work with a guy who, I worked in a kitchen, and when you work in a kitchen, you get really hot and you have to drink a lot. And so we used to drink water just by the pitcher. And this guy, Lauren, I used to work with, was famous for salting your water if you weren't looking. You'd be in the middle of a shift, and all of a sudden, you'd just reach over and grab your water and take a big glug of it, and he'd dump like 6 pounds of salt in it, and it would be the grossest thing in the world. And then he'd be like, sorry, I'm just going to hand you a water bottle, and it would be vinegar. Like, he would just do this to you all day. But he could do that because those were mixtures where you couldn't see the parts. Also because there was something deeply wrong with Lauren. On the inside, like morally. But again, his brain, he also, this guy, when I eventually stopped working in the kitchen, I was managing. And so like I'd go to a table that was complaining, and he had one of those, you know, the hand buzzers that like when you shake someone's hand, it zaps them? Well, he would put that up, and while I was talking to a table, he'd just come get me in the back of the neck with it. And then I would like contort and like make awkward sounds, and they'd just keep walking, and it was pretty funny, but I wasn't mad when he moved to Vancouver. But this is the other type of mixture we call a solution. And a solution is a mixture where we cannot see the individual parts. I'll give you a minute to write that, and while you write that, I'm going to start drawing yet more beautiful art. If we go back to the things I had lying around, my nail water ended in a lawsuit, so I stopped that as a great business scheme. But I still had some water, I still had some salt, and so I decided just to sell salt water. I'm going to have to come up with some clever name for it. But this is salt water. Now, what do you notice? It looks just like, yeah, again, as long as we don't put too much in, as long as you don't put so much that it can't fit anymore and it becomes a mechanical mixture, just a little bit of salt will make what we call a solution. And when we do that, if I took this and zoomed in, what I'm going to see, I'm going to see the water, and if we remember about water, it looked like that. So we've got our water hanging around. Maybe we'll put those there. But what else am I going to find in there? Not just the water, but also that's right, also the sodium chloride. And I'm going to cheat a little bit. You can yell at me when you get to grade 12 chem. But for now, we're going to just keep these stuck together. That's not really how it works, but shh, it can be our secret. All of which is to say, that's water, and that's salt. But that can only be seen at beyond even the microscopic level. If you took salt water and put it under a microscope in the lab, you still aren't going to see water and salt. It's still going to look like one thing. You would really have to be able to look at it at the atomic level, which we are not able to do, to be able to see the individual parts. Does that make sense? So this is a mixture with only one phase. You can really only see and I know we've already said that, but we're just going to repeat it. You can't see the different parts. It all looks to be the same. So if we said the previous one was heterogeneous, because you could see the different parts, what is the opposite of heterogeneous? Meaning you can see the other parts.
Homogeneous.
Yeah, very good. Homogeneous, which is often pronounced homogeneous. Both pronunciations are perfectly acceptable. But yeah, homogeneous or homogeneous. And I think this is the one that is spelt a little differently, so if somebody can do a spell check on this one, I'll try not to screw it up. I think this one does not have an E there, but it might. Can someone do a check on that for me? I struggle with spelling. It does have an E? So it's homogeneous, yeah? Like that? That looks wrong to me. But I'm going to trust you guys to check for me.
I think it's fine without me. I'm not getting it.
You're finding it without? Maybe it's one of these words that has just two spellings, and thus I'm driving myself crazy over nothing. It likes either. Interesting. So I'm going to put or. That way you know you have choices. Is this like how the British call it aluminium and we call it aluminum?
The way they call it what?
The British call aluminum aluminium. They have a whole extra syllable in there. And like they spell it differently too.
But why?
Well, those came first, really. So the question is, why did we cut it down? And the answer is because we're lazy. Same reason the Americans just took all these words that had U's and said, what if we just didn't? What if we just did that?
That looks wrong.
Which? Without or with?
Without. Like it has to have.
I like the U, but
It's just spelling of-
do you know who did that? That's actually very famously. Have you ever heard of Webster's Dictionary? The guy, Webster's Dictionary was like a huge mass hit. Like you don't think about it now because you can just look things up on the internet, but like dictionaries were actually really important. In fact, even like great literasts, like great writers, like Shakespeare, his spelling is all over the place, including his own name. There are times when he spelled his name with the E and sometimes without. Yeah, because, but spelling before the dictionary was kind of really fluid. It was just kind of like sounded out. And then when the dictionary, first Oxford English Dictionary, and there's a couple more, but then in America, the big one was Webster's Dictionary, that like formalized spelling. And guy Webster was a big believer that we should make spelling easier, and he liked the idea of kind of cutting away from the British, so he liked the idea of doing away with British spellings. So he suggested all sorts of odd spellings, some of which have hung on, some of which would get you made fun of by your parents. But how did he think we should spell was? W-U-Z. That one never really took off. Is for is. He had all kinds of spellings that it's funny, if you were to write them down, your parents would be like, oh my God, the internet made it so you can't spell. But like that's what Webster was suggesting 100 years ago. So there you go. Yeah. Yeah, I'd love to. That's what I'm here for. I get paid the big bucks to help. So you just want to go to Class Notebook. And then there'll be, actually just go down here.
I was writing on.
Yeah, that's okay.
I'm doing this.
That's okay. Click here. And then just go down to 4.1, and it'll be the B. Yep, there you go. All right, and homogeneous. Homogeneous means the same. Just like homosexual means somebody's sexual preference is the same gender as theirs. Homo means same. So that word kind of makes sense. It looks all the same throughout. So we classify that as a solution. That is the worst writing anyone has ever done. I'm sorry. Let me try that again. All right, and then there is a last category, which is really a kind of solution, but it is important enough to warrant its own mentioning, which is when we make a solution out of metals. When we make a solution out of metals, we call it an alloy. To make a solution out of metals, what do I have to do with both of these? If I just put them together, will they make a solution? No, you can take your tin and take your lead. Don't play with lead, it's poisonous. But if I put them together, they're just not going to do anything, so I have to melt. Very good, I have to melt them. And so if you heat the lead and heat the tin up, you get something that we call soldered. It used to be that when we not welded, but when we soldered pipes, has anyone ever done any basic plumbing around the house? Anyone ever soldered pipes before? It's super fun. So you like buy some copper piping and say you need to put a new sink in. Then you cut all your copper piping, it comes with joints, and you put it all together, but of course it just fits loosely. And then what you do to hold it together, you don't want to melt the copper because it would be hard to keep its shape, right? So instead you get a softer metal that melts at a lower temperature, and you melt it, and you let it fill the gaps between the two copper pipes. And so it's really fun because you line the fittings with a compound called flux, which is basically just a compound that will burn away as it heats up. And so the metal kind of gets sucked in to take its place when you melt it. And it's a really fun thing to do. But when they first started making piping, what did they use to make solder? Lead and tin melted together. What's the problem with that? Lead is very poisonous. So if you live in an old home, some people think that the pipes themselves were lead. That typically wasn't the case. But in a lot of older homes, or even worse, older cities and towns and buildings, all of the pipes are joined together with lead solder. And so the problem with that is, as water flows through them, what does it bring with it? Lead, which is poisonous. This is a big problem, and it's been a big problem in poorer communities. In richer communities, houses tend to get renovated and they tend to have had the piping updated. And in southern Ontario, even if you're not from a rich community, I mean, I grew up in Niagara Falls, it certainly wasn't a rich town, but it was sort of wealthy enough that when building codes were updated, if you sold a house that had old lead solder in it, all the piping had to be ripped out and they had to do new ones. But in a lot of poorer communities in Canada, especially in native communities in Canada, and a lot of poorer communities in the States, there's still houses that have lead solder in their piping, and that's a dangerous thing because it makes people sick, and it's a long-term thing. You can't cure it. Yeah?
Is asbestos similar to lead? Like I know that all houses, is that like solder?
Yeah, asbestos is totally different. Asbestos was a type of insulation, and it's very good insulation. It was a very good product for what was for. What does insulation do in your house? Keep it warm. Yeah, it's just a big blanket for your house. So if you go into the walls of your house, especially the outside walls, or if you go up into the attic, you've got layers of insulation. And for most of you, that's probably that pink fiberglass. That's the most common product now. Has anyone ever seen that before? It's awful, scratchy, horrible stuff. But that is relatively safe stuff. It's not nice. You can see it causes microabrasions. You definitely don't want to breathe it in, but it's largely safe. Asbestos was a product that was fireproof, which is good for insulation, because if your walls catch fire, it will slow the fire, not speed it up by also catching fire. That was a very good insulator. The only problem with it was it made particles, when broken down to its individual particles that could float in the air, they would get into your lungs and they could cause lung cancer and other lung diseases. So it's been outlawed, but you still find it in a lot of buildings. The first house I bought still had asbestos insulation all in the basement. And so we hired a company to come in and remove it all. And then they came in and they do tests and they make sure they have in fact removed it. But like that was an expense we weren't banking on. My wife and I didn't have a whole lot of money, but that was something we had to do. Like after we bought it, like we knew from the house inspection, but you know, we knew that before we could get insurance for our house, we had to have a company come in and take all the asbestos out. Yeah.
Isn't asbestos in apartment ceilings?
Yeah, a lot of older buildings. A lot of older buildings. A lot of schools. And the funny thing is what they found is that in a lot of cases, if it's sealed up in the building, it's actually a lot safer just to leave it there. So in the 80s and 90s, they were going into every building imaginable and ripping it out. And what they found, of course, is in the process you're stirring it up. And sometimes, if it really is properly sealed away, the best thing to do is just to leave it where it is, because it's not causing any harm. Does that make sense? So sometimes it's in buildings, and it's better just to leave it in the building than to stir it up. But if you are going to stir it up, don't take it upon yourself to remove it yourself. You know, hire a professional. They'll come in in hazmat suits and do it properly and keep themselves safe and keep you safe. It's important. You know, the sickening thing is Canada is still the world's biggest producer of asbestos. It's illegal to use in Canada, and yet we produce massive amounts of it, and it's a billion-dollar industry, and we sell it to poor countries where it's still used. So that's kind of something sad and depressing to think about today. I believe that. I'm contributing to it. Anyway, less so now. Been working on it. So an alloy is a mixture of metals. An alloy is a mixture of metals, and it is similar to a solution, but keep in mind that you can't make an alloy just by putting them together. You typically have to melt them. Most of the metals you deal with are alloys. In fact, I'm going to give you a little bit of homework here, which is not a big one, but I want you to research some common alloys. I'll give you one here. If I wanted to make steel, does anyone know how we make steel? What that alloy is? What's the main metal in steel? Who knows? Steel is an alloy of...
Is it iron?
It is iron. Very good. So you take iron. The problem with iron is that it is, relatively speaking, it's relatively brittle. So if you have anything that's just wrought iron, it has a habit of cracking and breaking under high stress. And so to make something that is stronger, they mix iron with, does anyone know? I'm sure they do mix iron and tungsten, but that's not a required element of steel.
Copper?
Nope. No. It's actually an interesting one because it's not actually a metal.
No.
But we still consider it an alloy. The base is the metal, and then it has to have in it carbon. Yeah. So steel was one of the early, not super early, because it couldn't happen until we had, forges that could melt iron, which is a lot of heat to melt iron. But once we could melt iron, all you have to fold into it is carbon, and carbon is just ash. So it's actually a relatively easy one to make if you can get hot enough to melt the iron. Of course, before we could melt iron, we could melt copper, and we could melt aluminum, so we were able to make things like brass and bronze come before this. But the steel age comes when we were able to make forges hot enough to melt iron. It takes a lot of heat. A lot of heat. You put iron in your backyard fireplace, not going to melt. It'll get nice and red hot. You might be able to shape it, if you get an anvil and a hammer, but you won't be able to melt it. It's a lot of heat. All right, I'm going to be quiet. I'm done. Your homework today is not big. Not big at all. There's a list of things here, and I want you to classify these as a pure substance or a mixture, and I think I've already changed your copy of this. Once you know that, if it's pure, I want to know if it's an element, or what's the other one? Compound, good. And if you decide it's a mixture, I want to know if it is a mechanical mixture or a solution. Good. All right, so that's an easy one. This won't take you long. And then do a little bit of research into alloys, and that also won't take you long. Today's homework, really, really, really short, really brief. Hey, why did Mr. Orlando do that? Why did he give us really little bit of homework today?
So we can work on past things.
He is not cool. Why?
So we can work different times when we finish past things.
Bingo. Because I know a lot of you have a few things to get caught up on, so I just want to give you time to do that. All right? So that's your task for today. I'm going to be quiet, and you can get